Acha ji, we are getting started with the questions related to the kinematics of variable acceleration. कुछ क्वेश्चंस हम लोगों ने उस दिन डिस्कस किए थे ऑन द व्हाट्सएप ग्रुप. बहुत सारे क्वेश्चंस अभी डिस्कस करने वाले. Let's look at the first question that needs discussion. That is this particular question. Have a look at the board. Question number 5, it says a tractor starts from rest and travels along a straight road for 500 meters. The VT graph for the journey is shown below. The graph consists of 3 straight line segments. Find the distance traveled by A, the initial acceleration of A. The first two parts are pretty simple. You find the total area under the graph, which is a triangle, which is then a trapezium, and then a triangle. And then you find the initial acceleration, that means during the first 100 seconds, that comes out to be 0.048 meter per second square. The first two parts go for 5 marks. Now there is another tractor, that is tractor B, that starts from rest at the same instant as A and travels along the same road for 500 seconds. That means the total time for both the tractors are the same. But this time it's not it's not moving with constant acceleration. It's moving with a variable acceleration. That's why an equation related velocity and time is given. Because with each different time, the velocity would change. Acceleration in terms of t, displacement in terms of t. So for different values of t, you'll be getting different acceleration and so on. How much greater B's initial acceleration is than A's initial acceleration? That means what we can do is that we can differentiate, have a look at the board. We can differentiate the velocity equation, we get the acceleration equation. Initially means time t is equals to 0. Now the word initially means time t is equals to 0, but when we were dealing with the constant acceleration part, we were dealing for 100 seconds. So therefore, those 100 seconds, the acceleration did not change. So there it was calculated using the gradient formula. When we look at the board, we have the acceleration equation. We plug in the value of t is equals to 0. The acceleration comes out to be 0.06. That previous acceleration for tractor A was 0.048. You subtract the two, you get the answer as 0.012 meter per second square. That is the difference between the two. Now, maximum velocity. Maximum velocity, what does it mean? It means that whenever they ask for something maxima, something minima, that means derivative of that particular expression, make it equal to 0. If they ask for maximum displacement, derivative of displacement equals to 0 will give you the time. You plug in the time in the displacement equation, you will find that value for that maximum displacement. Now over here they are asking for maximum this thing. They are asking for how much further B has traveled at the instant when B's velocity reaches its maximum. So how would I calculate the time for which B's velocity has reached its maximum? Have a look at the board. For maximum velocity, dv by dt equals to 0. In other words, acceleration equals to 0. You find the value of acceleration, you find the value of time to be 250 seconds. That means now you calculate what is the velocity when time is equals to 250. You can use the concept of collinear points, points lying on the same straight line. The gradient between these points are the same. First and the last point, everything is known. You can use the first and the second to find the value of V. Therefore, using the simple concept of gradient, you find the value of V, and V comes out to be 6.6 meters per second. Now, let me draw the graph for that portion again. During the first 100 seconds, we know that the distance is half into 100 into 4.8. During the next 150 seconds, that means from 100 till 250, we will find the value of the distance. That distance comes out to be, the total distance comes out to be 1095 meters. This is what the working was. Now if I move on, what do I need? I need the distance covered by tractor B, integration of the velocity expression between the limits 0 and 250 will give me the distance covered. Now some people, they asked this question in the WhatsApp group, and they asked, why do we integrate between limits? That is one question. Next question, what happens to C? Third, do we need an expression for displacement? Now, if I look at this, there are different answers, different ways of explaining this answer. First thing is, when we plug in the limits, the constant of integration is gone. We all know that. Second thing, we need the distance covered between two time intervals. And that is exactly the concept of area under graph. Imagine you have drawn the velocity time graph and you want to calculate the distance covered between 0 and 250. So that area under graph represents the distance covered. If someone integrates and puts a plus c and they use the initial condition when time t is equals to 0, the particle was at the starting point, or some other piece of information is given. So you can evaluate c. Once you evaluate c, you can now plug in time t is equals to 250 and you can find the value of that distance covered. So the difference between the two displacement, the displacement at 0 and the displacement at 250 will also give you the distance covered. But the easy practical method is, as far as the concept of distance is concerned, it's best that you use the limits unless and until the examiner asks for an expression. So if we look at the board, this is what happens. You integrate the expression, take care of all these zeros. Here your calculator will come in handy. Calculator that have the integration function with limits. Over here it's better that you use that option, you get the exact answer, you show the working over here, and then you can reconfirm your answer as well as you can minimize your working. You have shown the integration part. You can add one more step. First plug in the upper limit, then plug in the lower limit, and then you can write down the answer, which is 1250 meters. That means tractor A covered 1095 meter, tractor B covered 1250 meters. What is the difference between them? The difference is 155 meters. Another question to look at. A particle P starts from rest at O, travels in a straight line. Its velocity v meter per second at time t seconds is given by such and such. Now there are two expressions for velocity. One is between 0 and 3, the second one is from 3 onwards. The distance traveled by P in the first 3 seconds. Again, it's not asking for the velocity displacement expression. So all you do is integrate and plug in the limits 0 to 3. In the second part, it's asking an expression in terms of t for the displacement of P from O valid from t is greater than 3. Now, if I look at the first part, that was simple integration between limits. Now remember, you people are doing P3 and you have solved a lot of differential equations. What is differential equation all about? You have dv by dt, variable separable. dv is integral of something dt. Integrate both sides. So you get v, you get s is equals to something. Let me rewrite it. What are you saying? If I have dv ds by dt, velocity is ds by dt. Therefore, ds by dt is some expression. Therefore, ds is some expression multiplied by dt. Integrate both sides. What happens? Over here you get s and you get something plus a. That is the knowledge that is being applied in this one. I have to use an initial condition. When t is equals to 3, s is equals to 18. How do I get this? I get this from here. इसलिए, because initially it starts from rest at O. When a particle is at O, the displacement from O is 0. After 3 seconds, the displacement is 18 meters. Yes, somebody could raise this objection that they're asking for t is greater than 3. That means they are asking for an expression because it's following a different rule. Perfectly right. But there is no harm, it's perfectly valid to use the condition that after 3 seconds, this is where the particle is standing. That means for this particular scenario, it has already traveled this much. Take this into consideration when you find the displacement equation. So displacement equation, expression for displacement, that is integration of 54 over t square, which gives me minus 54 over t plus c. You plug in the value of t is 3 and s is 18 and you find the value of c as 36. That is the second one. Have a look. Now in the third part, I'll just do it by one method only, and that is the easiest part. That is the easiest method. That is the value of t when the displacement from P from O is 27 meters. Now practically speaking, they can't be asking using the first expression because they haven't made us evaluate it, find it. That's one practical, pragmatic approach. The second approach is, we know that during the first 3 seconds, the particle covered 18 meters. That means it would cover more using the second expression. So all you need to do is this. You look at the board. S is equals to minus 54 over t plus 36. Plug in the value of s is equals to 27. You find the value of t as 6 seconds. They are not asking only for the time, which of course is a necessity. They are asking for the velocity. So plug in the 6 seconds in the velocity equation and you will find the value of v as 1.5 meters per second. So now these two were very, very important questions that need to be thoroughly explained, even though I've given the solution in the WhatsApp group. Now let's move on. This is another question that needs our attention. A particle P starts from rest at the point A and travels in a straight line. Coming to rest again after 10 seconds. The velocity time graph of P consists of 2 straight line segments. A particle Q starts from rest at A and at the same instant as P. There are 2 particles. These statements, they get a bit lengthy. Particle Q starts from rest at the same instant as P, travels along the same straight line. Velocity of Q is given by such and such. The displacement of A of P and Q are the same when T is equals to 10. That means they're going to take the same time. And in that same time interval, they will be at the same place with respect to A. Show that the greatest velocity of P during its motion is 10 meters per second. Now the greatest velocity is what is occurring at 5 seconds, but we cannot see it because we don't have any extra information to find it. If I have the distance covered during these 10 seconds for particle P, I can use area under a graph and find the value of V. But how would I evaluate? How would I evaluate this particular distance? Let's see. Velocity is this expression. Displacement, since they are covering the same distance in the same time interval, which is 0 to 10, integrate this expression and find a value of displacement, which is 50 meters. Displacement of P should also be 50 meters. So half into base into height should equal to 50. Therefore, V comes out to be 10 meters per second. Therefore, the maximum velocity attained by particle P is 10. What is it asking now? Find the value of T in the interval 0 to 5, for which the acceleration of Q is the same as the acceleration of P. Acceleration of Q is derivative of velocity expression. Acceleration of P during the 5 seconds remains the same because it's a straight line segment. Gradient is fixed, slope is fixed. Slope of a velocity time graph is acceleration. That is 2 meters per second square. So take the expression for acceleration of Q, 3 minus 0.60, equate it to 2. So the time comes out to be 1/2/3 second, 5/3 seconds, or 1.67 seconds, whichever method of writing you feel appropriate. So that was the second question. The third question that we discussed, question 17. Another question to look at, question 19. It says a man walks in a straight line from A to B with constant acceleration 0.004 meter per second square. His speed at A is 1.8 meter per second. Speed at B is 2.2 meter per second. Find the time taken for the man to walk from A to B and find the distance AB. Constant acceleration, equations of motion are valid. You have acceleration, you have initial velocity, you have final velocity. You can use V is equals to U plus AT. You can find the time, that comes out to be 100 seconds. You can find the distance, that comes out to be 200 meters. Using V square is U square plus 2AS. That is the info that you get from the first. Now it says a woman cyclist leaves A at the same instant as the man. She starts from rest, travels in a straight line to B, reaching B at the same instant as the man. That means two things are the same. The time interval is 100 seconds, the distance covered is 200 meters. The expression is given by K bracket 200t minus t square bracket closed. Find the value of K, find the cyclist speed at B. Using the same axes, draw the VT graph for the man's motion and the woman's motion from A to B, the journey. Now have a look at the board. Velocity is this expression. We know that the displacement, the distance between the points 0 and 100 is 200 meters. So if I integrate the velocity expression and if I integrate the velocity expression and plug in the limits 0 till 200, 0 till 100 and equate it to 200, I'll find the value of K. Sure. When T is equals to 100, VW is 0.003, 200 into 10 minus 10 square. So velocity of the woman at 100 seconds comes out to be 3 meter per second. Now we'll be using this value when we will draw the velocity time graph forward. Now this is how the graph looks like. For particle A, for the man, it's a straight line. 1.8 till 2.2, it should be realistic in a total time of 100 seconds. But for the woman, it's a quadratic curve because the velocity equation was quadratic. I can further testify to the fact that it will reach its maximum velocity at 100 seconds. Because I can do a bit of differentiation. I can say, not as such differentiation, it's already differentiated. I can say velocity equals to 0. Therefore, 200t minus t square is equals to 0. T common. T minus 200 is equals to 0. Actually, it does not reach a maximum. It's still going towards the maximum. When t is 0, when t is 200, so at 200 seconds, it would reach its maximum. That will be the turning point. But we don't need the turning point as of now. No, hold for a second. This is not the turning point. These are the x-intercepts. These are the roots of velocity time graph. Therefore, the graph would be like this. This is 0. This is 200. Since it's a quadratic curve, it is symmetry. Therefore, at 100 seconds, it would reach its maximum. If I was asking about when the displacement will be max or min, that would be at 0 seconds, the displacement would be minimum because it would be at the starting point. At 200 seconds, the displacement would be maximum because that is one of the time value at which the derivative of displacement is 0. Have a look. Okay, now let's move on. Question number 30. A vehicle moving in a straight line, velocity at time t seconds after the vehicle starts is given by v is equals to an expression for the first 15 seconds. V is another expression for greater than or equal to 15. Now this is June 2010 and a similar question that we discussed in which there were two expressions. This was 2005 November. That means this issue of only a greater sign that might have caused problem for some students. So what the examiner did is that they made changes to this question, and now they are saying that t is 15 is inclusive in the first expression as well in the second expression. So that means if I have a displacement value, a velocity value at 15 seconds from the first expression, I can use it without any hesitation in the second expression too. Now it says the distance traveled by the particle between 0 and 15 is 225. Find the value of A and show that B is 3375. First thing first, integrate the first velocity expression between the limits 0 and 15, equate it to 225. Integration of velocity gives you displacement. You plug in the limits, don't worry about C. What do you worry about? You worry about finding the constant A, and A comes out to be 4. When you plug in t is equals to 15 in the first velocity equation, you get a value which I did not evaluate because I believe in evaluating at the very last moment. That same velocity should also be obtained from the second equation. So velocity obtained from the first, velocity obtained from the second in time, in that exact time interval of 15 seconds will give me the same thing. Have a look at the board. Therefore, the value of B comes out to be 3375. So that's how you evaluate A using the concept of integration between the limits. And how do you find B? Using the concept that at 15 seconds, whether you obtain velocity from the first or the second equation, it will be the same. Let's move on. Find an expression in terms of t for the total distance traveled by the vehicle when t is greater than or equal to 15. That means we know that when t is equals to 15, displacement is 225. This will be our initial condition. for solving the differential equation for the second expression. Have a look. T is 50, S is 225. S is B, integrate the function. We are not putting in any limits because we are working for the expression. Now you plug in the conditions. S is 225, T is 15, and B is 3375, which we already know. Therefore, C comes out to be 450. Therefore, S is 450 minus 3375 over T. This is the expression for the total distance covered. Now, what is it asking? It's asking find the speed of the vehicle when it has traveled a total distance of 315 meters. We know that the first expression is giving us a total distance of 225 meters in the first 15 seconds. That means 315 would be covered using the second expression. So just like that November 2005 question, this June 2010 variant 1 question would be solved the same way. 315 equals to the newly found expression for displacement. You find the velocity to be, you find the time to be 25 seconds. Plug in the velocity equation. You find the velocity to be 5.4 meters per second. Have a look at it. All clear? Now, another good question. Question 37. A particle P travels in a straight line. It passes through the point O on the line with a velocity of 5 meters per second. Using this first statement, there are two conditions that I can use whenever the need arises. The first condition is it was at the origin. That means initially time t is equals to 0, displacement is 0. That's the first thing. Second is obvious, t is equals to 0, v comes out to be 5 meters per second. The expression is given. The velocity of p is increasing between this and this limit. The velocity of p is decreasing between such and such limits. Find the value of t1 and t2 and the distance OP when t is equals to t2. Now the problem is the velocity equation is a cubic equation. And people give m1 with p1, people give m1 with p3. A p3 person knows how to draw a cubic equation. A p1 person does not know, but they go through a bit of detail if increasing decreasing function is taught properly. So basically what they are trying to say is that even if you don't know how to draw a cubic sketch, you can draw it using the concept of increasing decreasing function of p1. Now first of all, it's asking find the value of t1 and t2. What you do is that displace the velocity, take the derivative of velocity, which is acceleration. And velocity is increasing decreasing. Whenever we have to find the increasing decreasing range for a certain function, its derivative should be greater than 0, its derivative should be lesser than 0. Now we are not actually solving for the inequality as such, because we already know t1 is lesser than t2. So if I simply equate the acceleration, the derivative of velocity, that particular expression equal to 0, I'll find two times. One comes out to be 10, the other one comes out to be 30. The smaller one is t1, the bigger one is t2. Simple. The distance OP when t is equals to t2, that means integrate the expression. This time I'm evaluating the constant of integration. I'm saying that when t is 30, v is 5, and when t is 0, s is 0, Actually, that thing I need to correct it. This is t is 0 and v is 5, but I don't need it as such right now. When t is 0, s is 0, therefore k comes out to be 0. When t is 30, s comes out to be 285. That means if I want to, I could have integrated it between the limits 0 and 30. Now, the third part. Find the velocity of p when t is equals to t2 and sketch the velocity time graph. Actually, that thing was correct. That is after evaluation. I thought I wrote it down wrong. After evaluation, t is equals to 30, v comes out to be 5. Now we need to draw the velocity time graph. We know that if coefficient of x cube is positive, the graph starts from top right till bottom left, something like this. One of the turning point is t1, the other turning point is t2. Negative slope between t1 and t2, decreasing function. Positive slope right of t2, left of t1. I have discarded part of the graph that is to the left of the y-axis because time cannot be negative. That means t1 is 10 seconds. T2 is 30 seconds, and that's how the graph is drawn. So anyone who is doing P3, this is basic, but someone who is giving M1 with P1, this was kind of tricky. They needed to have the concept of increasing, decreasing thoroughly.